Hi, welcome to the series on page split and fill factor. This is the third video in the series. If you watched the first video, we talked about what a page split is and why we have started creating this series to begin with. The second video focused primarily on what is page splits per second counter and why you should be using it. And this video is going to talk to you about how you can use fill factor to control some of the negative side effects of page splits. To begin with, what we're going to do is we're going to continue using some of the stored procedures that we had previously. So I'm just going to go ahead and pause the performance counter so you can see that we've got the performance counter page splits per second being monitored. And we have the procedures from last time. Just to recap, the first procedure inserts data into a table called my data after truncating the table. And what it basically does is inserts data but skips every fifth row. The next procedure is the insert fives, inside which we go ahead and start inserting the fifth row, therefore causing the page split. Now what we're going to do is we're going to start off by first using a fill factor of 100%, which basically means that we're not doing anything to alleviate the problem. We're just leaving it at 100% and hoping that whatever data we insert will be fine. This is basically what was recommended in the video that I was talking to you about previously, but I'm going to show you why you don't want to be doing that and why you want to try and use a reasonable fill factor. To be clear, I'm not encouraging you to set a fill factor for each and every table because a lot of the tables are static. They don't really have a lot of that changes that might cause page splits. I've also mentioned in the first video how you can control some of the behavior by using identity columns, etc. In situations where you can't really do something about these kind of design practices is where you might want to set the fill factor. And to be honest, I think the point that I think was missed out in the video that I was talking about was fill factor needs to be set, but if you set it incorrectly, it's going to be useful. So rather than say that fill factor is useless, it would have been more correct to say setting an incorrect fill factor is useless. So let me go ahead and show you what I mean by that. Now I've got 100% fill factor here, which is kind of what was suggested in that video. And I'm going to go ahead and run my procedures. So I'm going to say, let's insert about 100,000 rows into the table. Actually, let's make that 600,000 rows. Right. And if you remember from the previous video, when we do that, what happens is the page splits per second counter will spike up and we'll get something like this. We know that this is the behavior. Now this is all well and good. We already are familiar with this behavior, and what we wanted to try and highlight was, in spite of this behavior, what typically happens is when you start actually doing the fragmentation, like how I'm going to start doing here now. So let's say around 100,000. Yeah, so just give it a second. We need a good amount of data inside the table before we can do it, so we can actually see some proper fragmentation happening. Otherwise all you'll see is one temporary spike as soon as it overlaps and moves on to the next. So let's do this. I think we have sufficient data at this point, so I'm going to go ahead and run this, and there is our spike. So this is basically the behavior that I wanted to try and tell you that you don't want to be doing. So you can see, in spite of this, it's turned out to be a fairly small spike to begin with. Correct. So this is what happens when you set 100% fill factor. Correct. Now let's go ahead and do something else. Let's try changing the fill factor of this to 70%. Right. So I'm going to go ahead and do 70%. And now I'm going to run this again. And what I want to try and highlight here is, notice that I didn't rebuild the index. I mean, I rebuilt the index, but what I'm doing is I didn't rebuild the index while we were inserting data in the previous run. And I'm not going to do that here as well, so that I can just show you what exactly happens. So you'll see again we have the spikes, not spike basically, but the standard behavior as before. Nothing fancy happening there. And then I'm gonna start inserting my 100,000 rows here. And again, just like before, you'll see that we have that massive spike. So here, what I want to try and call out is setting a fill factor of 70% didn't seem to give us any benefit. It seems to behave exactly like how it was with the 100%. And if you look at it this way, it will seem like as if setting fill factor is not really a solution to the problem that you're facing. Now, the thing is, it's not just fill factor. If you look at all the presentations that I did before, I've been constantly saying it's not fill factor, it's fill factor and rebuilding the indexes. When you do both of these in concert, that's when you see the benefit of having a fill factor set correctly and how it reduces the impact of page splits. So now what I'm going to do is I'm going to show you how this whole thing works when you do it right. So let's go back to setting the clustered index fill factor to 100%. Okay, so there we go. Oops. Give it a second. And what I'm going to do is we need a good chunk of data in this so that we can actually see how this whole thing works out. So I'm going to say insert 1,000,000 rows, right? And just give it a second. So that we can see this side by side, what I'm going to do is I'm going to increase the duration of this particular performance counter to, let's say, 600. Yeah, so it should give us sufficient time to do a side by side comparison. Correct. Great. So now that we have that, I'm going to go ahead and run this guy who's going to truncate the table and start inserting some data into the table called my data. And we're going to wait for a few minutes while this happens. And what I'm going to do is, in addition to this, I'm gonna start rebuilding this index, right? So let me just go ahead and let's say rebuild, correct? And I'm just gonna script it out and leave it here. You can see the fragmentation is slowly increasing, right? So I'm saying rebuild da 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 da, but again, the fill factor is 100%, so we don't really need to worry about that for the moment. And I'm just gonna leave this in a loop where I'll say rebuild, but wait for a delay of, let's say, 1 minute, every 1 minute, correct? So this is my rebuild script, and you'll see as soon as I say rebuild, immediately the number of page splits has reduced to 0. But you'll also see as soon as the rebuild is done, you can see how it spiked up all the way back to whatever the standard rate was, whatever it was facing before, correct? And this is the issue that I wanted to try and highlight. So you can see here that the rebuild index temporarily gets rid of the fill factor, the page split issue, but as soon as the rebuild is done, we go back to this situation here. So now let's see what happens when I start actually causing this page splits by using the other procedure. So I'm just gonna say 500,000 over here. Yeah. So you can see that as soon as I ran the 500,000 script, you can see that it spiked up again just like before, and that's because none of the pages have any free space in them. So in spite of you rebuilding the index, all the pages are full and all the pages are going to be split because of the query that we just wrote. So in this case, you can see that 100% fill factor and rebuilding indexes didn't do anything to protect us from the number of page splits that's happening. You can see again we have the situation where after 1 minute the clustered index rebuild has happened, and then we go back to our excessive page splits just like before, correct? So this is the main problem that we want to try and address now. So what I'm going to do next is I'm going to go ahead and stop this. So we saw what happens when you follow the recommendation given before. So let's stop this. And now what I'm going to do is I'm going to change the fill factor of this to 70%. Yeah. There we go. Just give it a second. Could have truncated the table first, but that's okay. But I could probably truncate it right now. Oh well, it's done. Cool. So let's go ahead and do this again. You have the original spikes that we looked at, and now we have a 70% fill factor, and I'm running this query once again. and it's going to do the same behavior as before. So you'll see this portion of the query is going to look exactly the same regardless of which fill factor we use. And the reason for that is because fill factor doesn't really get respected until the index rebuild is happening. SQL Server doesn't bother looking at fill factor when it's inserting data into the table. So in this case, what's going to happen is until the first rebuild happens, SQL Server is still packing the data into the table at 100%. And you can see that my clustered index rebuild has just occurred. And this pattern is going to be the same. So this is again standard normal behavior. At this point, there are no page splits happening. We're just inserting raw data as it is. Now, I'm just going to wait a few minutes while this goes on. And what I'm going to do next is I'm going to start causing the page splits. Correct? So the intention here is now we're following the correct process of using fill factor in combination with rebuilding indexes to reduce the number of page splits. So I think like I'm just waiting for it to be roughly the same width as this guy here. All right, so once that's done, let's go ahead and execute this. Right, so when you execute that, notice that we don't see any spike in the number of page splits. In fact, our clustered index rebuild has just happened here. Right, so that's going to protect us from some of the page splits that's going to happen. So you can see here that when we do the clustered index rebuild, the page splits typically reduce to 0, but then immediately pick up back to 100% like how we saw before. But here, notice how the fill factor provides sufficient buffer that even after the clustered index rebuild, there is no page splits happening. There is sufficient free space in all the data pages that we don't really see the spike. Now, if I just wait long enough without rebuilding the index, at some point what's going to happen is all the pages are going to be so tightly packed that we will again see fill factor jumping higher and higher. So the point that I'm trying to make here is it's not just the one thing. It's not just fill factor on its own that takes care of page splits. It's the fill factor when used in concert with rebuilding indexes that's really going to show you the benefit. And the best example that I could try and give you of something like this would be how when you want to shrink the database, you cannot just shrink the database. It doesn't reduce the space. You need to first go ahead and make sure that you've taken a transaction log backup. It's the two things in concert that help make sure that the pages can actually be shrunk and released back to the OS. So that same similar concept applies here, where you've got two different things that need to be used in concert with each other in order to go ahead and make sure that the performance is predictable and behaving the way that you want to. So this video, I hope, clarifies how you want to be using page splits. How you want to be using fill factor to control the behavior of page splits. You can see clearly in the graph how much of an improvement that makes. So we've reduced the number of unwanted IO operations to disk by about half. And that's pretty much the goal as far as this is concerned. The next thing I'm going to try and show you in the next video is how the impact of doing all this is minimal. So one of the arguments being made in the other video was that when you do fill factor to 70%, you're wasting space, and as a result, you're increasing the amount of time taken to do backups or check DB or any of the other operations, and how that's not a good thing. But I want to go ahead and show you that that's not necessarily the case, and stay tuned for that. I hope you've enjoyed this video. Thank you for watching.